Alright, so here we go with Unit 2, Day 6. This is the last day of the unit, so this is it. We're going to wrap it up and prepare for a test after this. So it's all about absolute values. So we did some absolute value equations in the first unit. Now we're going to do absolute value inequalities. So kind of mixing two things together that we already know and put them into one. So I can set up and solve both inequalities to find, again, both. There's going to be two of them, two inequalities, to find the solutions to an absolute value inequality. So just as a reminder, absolute value is a number's distance. So remember, distance from zero. So an absolute value inequality is an inequality that has a variable in the absolute value bars. Okay, so like this, the variable is inside, that's an absolute value inequality. When we did absolute value equations, you might remember that we isolated the absolute value. So the absolute value, the bars we isolated, and then we did a trick and got the variable itself. So then we set that expression equal to the positive and negative value of the constant that it equaled. So a very simple example, when you have the absolute value equals 5, well, the absolute value bars are by themselves already. So we take the expression inside x, we set it equal to positive 5 and to negative 5. Okay. So however though, with absolute value inequalities, we will use the distance definition more literally. So we can't just say equal to. We have to decide, should it be greater than? Should they be less than? We got to do a little bit more work with that. So we got to use distance definition more literally. Okay. So when we see that the absolute value of x is less than 5, we say the distance from 0 is less than 5 units. So when we do this, absolute value is less than 5, that's distance from 0 is less than 5 units. So on the number line, to be within 5 units means that you are between -5 and 5. So here's 0. If my distance from 0 is less than 5, I could go 5 this way, I could go 5 this way, I got to be between there. Okay, so somewhere between there is where I'm going to lie. Okay, it could be any number in between. It's not just these numbers. It could be anywhere in between there. Okay, so we write this. Remember, when it's between, we write that as an and. So think about the last couple of days. When you had an and inequality, you shaded between because it satisfied both requirements. It was larger than this, but less than that. So it's an and statement, which means we put the x in the middle, we have the arrows pointing to the left, then go least to greatest, so -5 up to 5. Okay, so that would give us the inequality for this absolute value. When we see the distance is greater than 5, it's like we're being pushed away. So we say the distance from 0 is greater than 5. So on the number line, it would be more than 5 units away. So you'd be outside of -5 and 5. So here's 0, here's 5 units to the right, I'm beyond that. So I'm further over than that. Okay? So larger, more than that. So being pushed away. And then if I go 5 units this way to -5, I'm more than that. So I'm further away. So you get pushed out. If you remember from the last couple of days, when you're outside, there's no numbers that meet both of the criteria. So that means this is an or statement. So we would say that x is less than -5 or x is greater than +5. Okay. So it all depends on if it's if the absolute value is less than or if the absolute value is greater than. If you want to take out the word absolute value and put distance from 0, that might make more sense when you're doing these problems. Okay, so on the next one here, we've got the absolute value of 3x is less than 18. So the expression 3x has a distance from 0 less than Again, if it's less than 18, that means it's within 18 units of 0. So we can write that as the expression 3x. Again, think of this way. Here's 0. Here's 18 to the right. Here's 18 to the left. 3x is somewhere inside of there. So the expression 3x is larger than or equal to negative 18, but it's less than or equal to positive 18. Okay, so that's just the expression 3x. That's not x by itself, so I don't have my answer yet. That's just 3x is floating around somewhere in here. We want to find out what x values could make that happen. Well, first off, let's solve this. Okay, so I want to get x by itself, so I'm going to divide everything by 3. So divide by 3, divide by 3. Whoops, sorry. Divide by 3, so I'd have negative 6 is less than or equal to x, which is less than or equal to 6. So that means the variable x is between negative 6 and 6. Equal to, so close circle, and then connect between them. Okay. Well, let's keep going. It's a little bit more difficult. Okay, so now we've got a greater than expression. So let me move this up here. So I've got a greater than expression. The absolute value is already by itself. So the expression x minus 4 has a distance from 0 greater than. So again, take out the word absolute value and just say distance from 0 greater than 7. So it's beyond 7 units from 0. So we can write that as the x minus 4. Actually, if you need to visually think of this, so here's 0, here's 7 units to the right, 7 units to the left. X minus 4 is outside of that. It's larger than this distance. Okay, so x minus 4 is over here, or it's over here somewhere. Okay, so x minus 4 is less than, just less than negative 7, or it's on the other side, so or x minus 4 is greater than positive 7. Okay, so if x minus 4 is less than negative 7, let's solve for it. That means x is less than negative 3, or if I add 4 to both sides, x is greater than 11. So when I'm doing this, I'm talking about the expression, the entire thing. Here I'm talking about just the variable. So x is less than negative 3, or x is greater than 11. When I go to graph that, on time here. So this guy here, this expression is larger than 3 units. So just visually thinking, here's 0, 3 units this way, 3 units this way. It's larger than that. So the expression y plus 8, it's less than or equal to negative 3, or y plus 8 is greater than or equal to positive 3. Okay, so it's out somewhere in that region. Again, on both of these, subtract 8. I got y is less than or equal to negative 11, or y is greater than or equal to negative 5. Okay, so slap these down here. Equal to means closed circle, going out. Okay, let's keep going here. Number 2. Again, the expression is less than 9. So translate that. The distance from 0 is less than 9. So it's like being bound together between 2 points. So if I go right and go left, this x minus 5 is somewhere between here. So 2x minus 5 is somewhere in there. So that means 2x minus 5, it's larger than negative 9, but it's less than 9. So it's floating around somewhere between those two numbers. I'm going to solve for x now. So plus 5, plus 5, plus 5. Again, negative 4, less than 2x, less than 14. Again, divide everything by 2. So it'd be negative 2 is less than when x was less than 7. So the variable itself, x, is somewhere between -2 and 7. The expression was between -9 and 9, but the variable is what we care about. So the variable is between -2 and 7. Again, this is not equal to, so open circle somewhere in there like that. Okay, I want to have you do 2 of these. Okay, so for your notes, do these 2. So complete for credit. That means you do them. Okay, some of you are not listening to the videos, you're just watching and you're copying down complete for credit. That doesn't get you credit. I can't give you credit on your notes if you don't complete these. So do these for credit, for note credit. Let's go down to number 5. Okay, so a little bit more to do here. I'm dividing by -3. So don't start writing anything yet. First, we need to get the absolute value of x by itself. So I'm going to multiply both sides by -3. So now I've got the absolute value of x, and I've got -21. Because I multiplied by a negative, the sign switches. So the distance from 0 is less than -21. How can I have a distance less than -21? Okay, you can't. You can't have a negative in there, so that one is a no solution. There's no number that I can get a distance of -21. Okay. Let's see here. Number 6. So number 6, let's again get absolute value by itself first. So add 3. So I got the absolute value of x minus 4 is greater than 10. So the distance is larger than 10. I mean, this expression is outside of 10 units to the right and 10 units, so it's like that. It's less than -10 or it's greater than 10. So x minus 4 is less than -10, or x minus 4 is greater than 10. So add 4. X is less than -6, or x is greater than 14. Okay, so -6, 14, open circle left, open circle right, and I got it. Okay, now the last one, the one that people are confused on, but don't overthink this. Okay, don't overthink this. It just says the ideal circumference for women's basketball is 28.75 inches. The actual circumference can vary. It can go up or down by 0.25, which means the difference between this number and the actual number is allowed to be 0.25 above or 0.25 below. Okay, so I know you can probably maybe get the answer right now, but what we're saying is if I took the difference between your actual, so I just take a random basketball, I pick it up, measure the diameter, it's x units. How far it is off from 28.75, well, I can just subtract them. I don't care if it's more or less, so I don't care if it's positive or negative, I just want to know how far off it is. So I'm going to do the absolute value of it, and that needs to be within 0.25. So at most 0.25, so up to and including 0.25. So if it's less than, it's within those limits, it's bound together. So that means that x minus 28.75 is going to be larger than negative 0.25, but less than positive 0.25. I'm sorry, equal to. Okay, so let's add 28.75. So I got x in the middle. On this side, if you need to use a calculator, that's fine too, but it's 28.5. Over here, I've got 29. So as long as when I measure, if it's somewhere between 28.5 and 29, I am okay. Okay, so this is the acceptable circumference. Anything between those two numbers would be acceptable. Okay, so that's it. That is the end of day 6 and also the end of the unit. So let me know if you have questions.